Hi everyone, this is Mrs. Kovacs, and I'm going to be showing you how to solve a system of equations with substitution method. Before we start, two things. One, I'm sorry if you hear any background noise. There's some people outside my apartment right now. Two, I want to make sure that before we jump into the substitution method, which has a lot of algebra stuff associated with it, I want to make sure we understand what it means to substitute a value for something else. So we're going to start super basic with this nice little pattern and to help us understand what substitution means. So let's say we have this pattern that goes star, arrow, heart, circle. And I ask you to substitute, or I tell you that I want to replace circle with this like little rectangle thing. That means exactly what you think it is. Don't overthink it. That would mean that we would rewrite the pattern. We'd write star, and then we do our little up arrow, and then we do our heart, and the only thing that they're asking us to change is the circle. We're asking to replace it with this little square. And if you think that's easy, that's great, because that's really all substitution method is it gives you two things, and it says now replace one thing with something else. We're going to look at a slightly more algebra-ish example before we jump into proper substitution method. So we'll look at this expression, 2x plus 1, and it's telling us to substitute x equals 3. So what that means is I'm going to rewrite my expression, but instead of x, I'm going to plug in 3. And then all we have to do is evaluate what that's equal to. So 2 times 3 is 6. And then 6 plus 1 is 7. So again, all this was asking us to do was it gave us an expression, and then it told us to substitute one of the values for something else. Keep that in mind before you get overwhelmed by the algebra that we're going to be doing on the next screen. The first example we're going to look at, you can also refer to as the equal values method, and you're going to see why. So this consists of two equations, y equals 2x plus 3 and y equals 5x minus 3. You may recognize these because they're in what we call slope-intercept form, or y equals mx plus b. And oftentimes when we're given something like that, we're representing a situation or we're graphing. It's the same type of equation. But in this case, we're just going to be working with the algebra. So our first equation tells us that y is equal to 2x plus 3. Our second equation tells us that y is equal to 5x minus 3. In order to solve this, we're actually looking for an ordered pair xy, a number for x and a number for y, and when we plug it in, we want both equations to be true. We'll talk more about what that means after we've solved. So if we're going to solve, we need to be able to put this into just one variable. Notice how both of them have both x's and y's. We need to be able to isolate it down so we can solve for one x or one y. In order to do that, we can use the little substitution trick that we were talking about on the last screen. Again, it's going to look different, but don't let it be overly complicated. So here we have this equation. I'm just going to rewrite the second equation. Y equals 5x minus 3. But instead of y, I'm going to replace y with something that we know is equal to y. If you ever get confused, just read the equation aloud in your head. The first equation tells us that y is equal to 2x plus 3. So all we did was we took our second equation and replaced y with what we knew it was equal to from our first. From here, we're ready to solve. So we substituted, and now we're ready to solve for x. If you need a review of solving, I do have a video on that as well. The idea with solving is that first we want to get our x's onto one side of the equation. So to do that, I'm going to subtract 2x from both sides to get rid of this 2x on the left. That leaves us with 3 equals 3x minus 3. Next, we want to isolate 3x, and to do that, I'm going to add 3 on each side of the equation. to get 6 equals 3x. Again, if you get confused about like where you're adding what, I like to put this squiggle in the middle just so that I remember to be doing stuff on both sides of that line. Finally, our last step to isolate x is to divide by 3. And that leaves us with x, oops, wrong color. Still the wrong color. Come on. There we go. X equals 2. So now that we have 2, normally if we were solving an equation, we'd be done. But we're not solving an equation, we're solving a system of equations. So now that we have x equals 2, we're going to look back to either of our equations. I'm just going to use the first one, y equals 2x plus 3. Remember that came from the original equation, or the original system, right here. And I'm going to replace x with what we just found. So we found out that x equals 2, so I'm going to replace x with 2. And then all we have to do is calculate. 2 times 2 is 4, plus 3 is 7. So we substituted y, we solved for x, and then we plugged in x to find y. The last thing that we want to do is check our answer. So if you remember what I said at the beginning, our goal was to find a coordinate pair x, y that made both equations true, which means that we need to check both equations with our numbers that we found and make sure that it works. So our x and our y were 2 and 7. So I'm going to replace my y with 7 and my x with 2. All that we have to do here, no fancy solving, all we have to do is calculate. I use a calculator, there's no harm in that. And what we're looking for is a true statement. And in this case, we do get a true statement, which means that our first equation checks out. We can do it again over here. Plug in 7 for y and 2 for x. Calculate. And once again, we get 7 equals 7, which is a true statement, which means that the second equation checks out and we found our solution. You want to write your solution as a coordinate pair. So I'm going to write my solution x, y, 2, 7. So again, that was a special type of substitution called the equal values method. The reason they call it that is because we had 2 equations that told us what y was equal to, and we basically just set them equal to each other to solve. Let's look at a second example. So in this example, you can see it's a little bit more complicated because for example, like the second equation has an x and a y on the same side, and the first equation might not look as familiar because it's in the form x equals something, which when we were graphing or writing equations from situations, we didn't see as much. That's okay though, substitution is still going to help us out here. So our first equation tells us that x is the same or that it's equal to 3y minus 5. Our second equation tells us that 2x plus 5y equals 1. And what we're going to do is we're going to take our second equation and we're going to replace x right here with what we know x is equal to. So according to our first equation, x is equal to 3y minus 5. So all I'm doing is I'm rewriting my second equation, right? All this came from my second equation right here. But I'm replacing x with something that I know it's equal to. From here, that's like the main idea of substitution. From here, all it is fancy solving. Again, if you need a review of solving, I have another video on that. So in order to solve, the first thing that we need to do is distribute, because we have 2 times this expression that's in parentheses. So I'm going to multiply 2 by each part. 2 times 3y is 6y, and 2 times negative 5 is negative 10. And then all I need to do is rewrite everything else. I'm going to put my squiggle down the middle here to remind me where my sides are. A lot of people at this point want to do something that looks like this. But that is a super illegal math move, because remember that what you do to one side of the equation, you need to do on the other side as well. So rather than doing that, what we need to do here is actually just combine like terms, right? Over here on the left side, it's telling me that I have both 6y and 5y, and I can combine those to make 11y. And then I'll just rewrite everything else. I'm going to move this a little bit over here. Now we can start our typical solving from this much nicer looking equation now that we've distributed and combined like terms. We'll add 10 on both sides to get 11y equals 11. I usually use orange for this step, and that's really going to bother me, and so I'm just going to change this to orange, even though I'm probably the only person that cares. And then we're going to divide to get y by itself. And that is how we'd solve for y. Remember that we're not actually done here, because we still need to find what x is equal to. The thing I love about substitution method is that one of the equations literally tells you how to find the other variable. So I'm going to rewrite my first equation. You could use either one, but the first one's easier, trust me. And we're going to replace y with the number that we found. So remember that we found out that y was equal to 1, so I'm going to replace y with 1. And then I'm going to calculate 3 minus 5 is negative 2. So we substituted, we solved for y, and then we plugged in to solve for x. Now let's check our answer. Remember that to check our answer, we need to plug in our solution to both equations to make sure that it works. I'm just going to write that here. So I'm going to write my first equation and my second equation. And then I'm going to replace x with negative 2, because that's what we found. And I'm going to replace y with 1. No fancy solving at this step, just calculate. We get negative 2 equals 2 from our first equation. That's true. We're good to go for first equation. I'm going to highlight these so that we know for sure where they came from our original system. And then I'm going to do that over here. I'm going to replace x with negative 2, and I'm going to replace y with 1. And I'm just going to straight up calculate. We do get negative 4 plus 5, which is 1. So we get 1 equals 1. That means that we didn't make any calculation errors. This is the solution that makes both equations true. At this point, if you get a statement that is not true, you need to look back at your work and see if something went wrong. All right, so let's go over some things to remember. First up is, how do you know if you even want to use substitution method? Well, first you need to make sure that you have a system of equations. That means that there's two different equations, usually with x and y, but they could be any variable. And the second thing is that you need to have an equation that looks like x equals something or y equals something. So if you look back at the problems that we did, this right here, x equals 3y minus 5, told us that we could use substitution method. And right here, y equals 2x plus 3, told us the same thing. The second thing to remember is that you need to practice solving, or you're going to be making lots of mistakes and getting really frustrated because you're going to keep getting values that don't work, even if you understand the basic premise. So practice making sure that you're doing equal operations to both sides, that you're simplifying, distributing, and all that good stuff. Something else to remember is to only replace equal values. So you have to be really intentional about how you combine your two equations. You can't just smash two equations together because you want to. You need to make sure that you replace a variable with something that it is equal to. The fourth thing I see a lot is when people check their work that they only check one equation. You do need to check both equations because, again, by definition, solving a system means that it makes both equations true. So plug it into both and make sure it works. Last thing, make sure you solve for x and y. A lot of times, especially if you're like in a rush, you will just get into solving equations mode, like here, and you'll solve for y, you'll box it up, and then you think you're done because you just did so much work that you forgot that you were solving a system. Remember that for a system, you do need to have both x and y. Thanks so much for watching. I hope you learned something. Have a great rest of your day.